Now's the time in the show where Mr. Wise and I would like to make an electromagnet for you. Electromagnets are a very important part of your everyday lives. If you plug something in and hit an electrical switch and the device moves, spins, or makes a noise, I can guarantee you an electromagnet is deep inside working for you. In most devices, electromagnets are hidden. They're in the middle, center of something, inside a case. They're just hidden. They're in doorbells, automatic doors, speakers, microphones. Electromagnets really change your cell phones, so you can't tell us that electromagnets aren't important. To make an electromagnet, you need three things. And these three things, actually, Mr. Wise and I live by a code. And it has to do with those three things. And that code is current, coils, and core. So current comes from the battery charger right here. So if you take a look at the battery charger, we're going to get electrical current flow of electrons. Those electrons will come down the conductors and into the electromagnet. The core is a nail. In this case, it's a nail, but it could be anything, any chunk of iron, nickel, or cobalt. I mean, it doesn't have to be a nail. It can be just a chunk of steel because steel has iron in it. And then the coils, basically, you coil wire around that core, and the wire basically has an invisible electromagnetic field. And that field it kind of flows around that wire. It's invisible, you can't see it. So when current goes through a wire, it creates that electromagnetic field. We strengthen the magnetic field when we coil it. And all those coils work together. So far with this electromagnet, okay, I have 20 coils produced, and you notice how uniform and tight those coils are? It's very important. For those coils to work together and provide strength, they need to be very, very uniform and neat and tight. So I have 20 so far. Mr. Wise, turn on the electromagnet, please. And we dip down. We can prove that this thing's magnetic because it will actually pick up a small amount of those steel paper clips. So we're going to take those paper clips and we'll turn it off. And some of those do drop off. So if you think about a crane at a junkyard, it picks up a large amount of that metal and it can deposit it in a different bin simply by turning the electricity off. So this is a relatively weak magnet right now because we don't have many coils. So we're going to increase the order here, kick it up another notch to 40 coils. 21, 2, 3, 4, 25, 26, 27, 28, 29, 30, 31, 33, 34, 35, 36, 37, 38, 39, and 40. Now we doubled the amount of coils, so we should have doubled the amount of strength. I gotta go to lunch duty. Huh? Never mind that. Okay, Mr. Wise. Did the strength so indeed go up? And I guarantee it might even more than doubled. So that would be the strength of a 40 coil electromagnet. Turn it off. There's that junkyard crane thing. Think about it. Electromagnets are so useful because you can turn them on and off. A permanent magnet, it would just stay stuck. The magnetism could not be turned off. So that's one huge advantage of an electro. Let's double it again. 40 to, 60? 41, 42, 43, up over, 44, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I think we're good. I might have lost count there, sorry. I think we're now at about 60. So here we go. Mr. Wise, did we triple the strength? And take notice there, I think we have slightly more. Moving over to the other bin and turn it off. And our last trial here for the day, we're going to try to get up to about 80. So we want to go on to 61, 62, 63, 66, 70, 70, 1, 2, 3, 4, 5, 76, 77, 79, That's about as good as we can do. Okay, here we go. Now more than 4 times the strength than what we started out with. This thing's actually vibrating in my hands, and you can see it's quite a bit stronger. Notice the amount of paper clips. And Mr. Wise, go ahead with that junkyard style release. Okay. So in this experiment, your independent variable, if you can remember what that was what I changed was the number of coils, or the number of wraps. What we measured was the amount of paper clips. So as the wraps increased, what happened to the number of paper clips attracted? So we started off with a low amount, slightly higher, and the most paper clips that we could get there in this event. So we can make the conclusion that the electromagnet got stronger the more coils we put on. Some of the strongest electromagnets, I mean, they have thousands and thousands of tightly wrapped coils. We can increase the current to get a stronger magnet, and we can also increase the amount of core. I don't know if we have time, Mr. Wise, but this electromagnet right here has a huge core, many coils, and if we hook it up real quick, we might be able to show students just how strong it can be.
As you're watching Mr. Dairyman hook this up, make a prediction comparative to the size of coil. Let's just get a close-up of this.
There's, I think, 3 of those brown wires all spliced together, wrapped around this chunk of iron core. This gets pretty strong. Okay, Mr. Wise, we might be shorted. Are we on the right? Oh my gosh, yeah, we're on.
Now I'm going to release this, Mr. Dairyman, and I want you to put it there in the middle.
Okay, like right here.
Mm-hmm.
Yeah,
I'm going to turn it on. Now lift that up. Now why didn't we get the same result in the middle as we got on the end?
You want me to answer that?
Yeah.
Oh, well, on an electromagnet, the poles of any magnet are the strongest because that's where the magnetic field lines enter and exit. So if you think about the magnetic field, it's kind of bowing way out and going back in the opposite pole. Those lines of a force, they attract. So the field is strongest at the poles. And in some cases, that line of force you can actually see connecting with the paper clips if I got it close enough there. Okay, so basically, junkyard crane, turn it off. Same idea.